Hello everyone, welcome back to another video. My name's Nathan and today I'm going to be going over my Ultrix solution to day 3 of the advent of code. Now, hopping straight into the challenge, day 3 is all to do with an elf who's been put in charge of packing up a load of rucksacks. These rucksacks are represented by a single line of a bunch of characters. So if you can see this example here, all of these individual lines are their own rucksack. And what we have in each rucksack is two compartments. The first compartment is the first half of each line, and the second compartment is the second half. So basically, if we split all of these lines down the middle, they're the two compartments. Now, the challenge here is that the elf that's been put in charge of packing these rucksacks has messed up. So in each individual rucksack, both of the compartments should have different item types in them, which are denoted by the letters, so A through to Z. Um, and basically, each compartment should have its own unique set of items. So the challenge here is to basically find letters that appear in both sides of the string or both compartments, because that indicates a mess up. Because um, that type of item is no longer unique to an individual compartment, at least for that rucksack. It's important to note that lowercase and capitals, or uppercase, refer to different types of items. So, as you can see in the example, lowercase a is a different type of item to uppercase a. And then, sort of, the final part of solving this challenge, at least for part one, is that all of the letters, once we've gone through each record and identified the problem letter or item type, all of these have a priority assigned to them. So we can see here lowercase a through to z have values of 1 to 26 assigned to them, which are their priorities. And likewise, uppercase a through to z are priorities of 27 through to 52. So to summarize, part one, we need to go through, we need to split the rucksack in two. We need to identify which letter appears in both sides, and then we need to assign that letter's priority to it. Once we've done that for each record, we then just summarize all of the priorities, and that's our puzzle answer. So, hopping into Ultrix, exactly the same as the previous two videos. The first couple of fields can sort of be looked past. They're literally just bringing the data in. But once again, the download tool just leaves us with a single cell containing all of our data, whereas we want each of these lines to be its own record, which is, in this case, an individual rucksack. So again, much like the previous video, first step is just to split out the results of the download data into individual rows, and the delimiter for that is just a line break, which is our /n delimiter. Now we have our individual rucksacks on individual lines, so now we're just going to go ahead and split them into the two compartments. So if you remember, I mentioned that the first half is compartment 1 and the second half is compartment 2. So a couple of really easy statements to sort of achieve our two compartments here. We're just going to use the left and right functions. And what these do, if I start to type in left, for example, returns the first n characters of a string, where n is a number that we provide. But if you look at our input data, you can see that the length of a string isn't set. So, for example, if all of our rucksacks were 10 characters, then we could just provide 10 as the length. But because they're varied, we need to do this dynamically. And the way we can do that is by sort of nesting another string function inside of the left and right, which in this case is our length function. So the length function, again, I'll just start typing it in. Really simple, just returns the length of the string or returns the number of characters in that string. And because we are splitting this in half, we just do the length divided by 2. And then for compartment 1, that's the number of characters from the left or from the start of the string that we want to take. And compartment 2 is just the inverse. So again, we do length divided by 2, and we just take that number of characters from the end. And you can see here, if I just sort of lift up the results panel a bit, we have our rucksacks nicely split up into 2 halves, left and right. The next step is just assigning a record ID. This is because further downstream we're going to blow up our data a bit, and we want to be able to keep track of which rucksack these newly formed or sort of expanded records originate from. If you look forward a couple of steps, you can see that I use regex. This is just to split out each compartment into individual lines, so we can sort of analyze this letter by letter. And to do that, we first want to get our compartment 1 and compartment 2 values into a single field. So I'm going to achieve that by using the transpose tool, where we're going to end up with name value sort of pairs. So you can see here that our titles, or the names of our fields, compartment 1 and compartment 2, actually come into the data with their values next to them. And by unticking things like the URL, the download data, and the download headers from data columns in the transpose tool, that means that we've just cut them out of the results. So we end up without any noise. We just end up with exactly what we want, just the record ID and then the 2 fields ready for comparison. Now, as I mentioned just previously, we're going to use the regex tool to basically, in the same sense as our text to columns that we used before, we're going to use it to split these into rows. And we achieve this by putting the tool into tokenize mode, which means every time the pattern that we define is found, it splits it out either into columns or rows. In this case, we want each letter to become its own record, so we're splitting it out to rows. And the pattern that we provide is just a full stop, which in regex or regular expression denotes any character. And because we've not put a plus or an asterisk after it, in this case it means any single character. So Ultrix is basically going to, if we take the first record here, Ultrix is basically going to look through this, and any time it finds one of any character, it's going to split it out into a new record. So it's obviously going to put capital W into its own record. Then it's going to look ahead. This satisfies any single character, so it's going to put lowercase w onto its own line, and so on for C, S, B, and all the other letters. So if we look at the outcome of that, you can see that now compartment 1 is split out into a letter for each line. So is compartment 2, and then so on and so forth. And this is why we needed our record ID. So even though we've continued to split it out and blow up our data a bit, we can still see which rucksack and which compartment these letters belong to. Now, I maybe should have prefaced this by saying that these are just my solutions. In a lot of cases, they're probably not optimal and maybe very different to what other people have done. But yeah, I'm just trying to break down my solutions and my sort of thought process. So what I've done is basically split the two compartments into their own streams. And the reason I've done that is because I've sort of identified which letters appear in both compartments by doing a join. So if we first of all start with the filter, this is just really simple. We're looking at the name field and seeing whether that contains a 1, because if we look at the input, we've got compartment 1 and we've got compartment 2. So everything coming out of our true anchor is just compartment 1 values, and everything coming out the false is our compartment 2 values. And what I was saying about the join is that if we conduct a join on, first of all, record ID, because we want to make sure that we're comparing compartments from the same rucksack, and each rucksack is its own record ID. But the sort of most important or most prominent for this use join key is actually our value. So what we're actually looking at here is the individual letters coming in, and we look at the inner join. So if Alteryx manages to find, let's say for this example, if we look in compartment 1 at the lowercase w, if Alteryx manages to find a lowercase w in compartment 2, it's going to return that as a join. So we know that that letter has appeared in both sides of the compartment, which, going back to the original puzzle, would mean that lowercase w is our problem letter, so we would then want to find its priority and add that to the total. So there are our two sort of join keys. We use the record ID to make sure that we're only looking in the same rucksack, and we use the value to find or to pull out the letter that appears in both sides. And you can see the left anchor is everything that goes in the left hand side and doesn't find a match in the right. So again, going back to the original puzzle, these are all the values that are sort of unique to compartment 1, and the right hand side's the inverse. So these are all the values that are unique to compartment 2 for each rucksack. And yeah, as I mentioned previously, everything that comes out of our J anchor is all the values that have found a match between compartment 1 and compartment 2. So all the letters that appear in both sides, and the whole premise of this challenge is to find these. And the join puts things a little bit out of order, so just to make things easier to track as I was working through the challenge, I just ordered the record IDs again. Yeah, just so they're in numerical order. And you can see here that these are sort of our values that appear in both sides, and they appear multiple times. So all I'm going to do is use a unique tool, and we're looking in record ID and value. So if I go ahead and look at the input, this is going to return the first record of each combination of record ID and value. So here we've got record ID 1 and the value is S. So it's going to pull that out as a unique value, and then when it goes to line 2 and finds the same one again, Alteryx is going to identify that as a duplicate, so it's going to get rid of it. So if we look at the output, the U output denotes unique values. So you can see here that we just get a single value for each record ID or each rucksack, which is exactly what we're after. Now, that's all well and good. We've pulled out the sort of problem letters from each rucksack. But if you think back to when I was going through the actual puzzle itself, what we want to do is find the priorities that are linked to these letters. So I've just sort of made a lookup here. So our characters A to lowercase z were 1 to 26, and uppercase A to Z were 27 through 52. So I had again, all I've done is conduct a join. So I'm looking here S, J, Z, and so on, and I'm just matching the sort of lookup value to that and returning the priority that belongs to it. And you can see here I'm just doing a little bit of renaming. So one of the good things about the join tool in Alteryx is that it's got built-in select functionality. So you can see here I've deselected the incoming character field from the lookup because it would just be a duplicate field. It would just, for this record, for example, it would just return lowercase s next to it. But yeah, I've renamed the incoming record ID field to priority. And as you can see here, capital B priority is 28, C is 29, and so on. So now we're ready for the final step, because the whole purpose of part 1 here was to identify the problem letter, which we've done so. We've now assigned a priority to it, and now all we want to do, much like in my first couple of videos, is to summarize the total once we've looked through every rucksack. And to do that, we're just using the summarize tool again. So we've got all of our priorities, and I'm just using the sum function, which for part 1 returns 7,850. If we flick over to the Advent of Code site, that was indeed our part 1 input. So fairly straightforward, a few more steps than the other 2 videos, but again, nothing too crazy. We're not sort of introducing any macros or any ridiculous logic yet, as you'll see in later videos. But yeah, good chance to try out some different tools to what we've used previously, where we've pretty much just had to use formulas and summarize tools. So, hopping into part 2 of today's challenge, we basically want to do the same checks, but instead of splitting each rucksack into 2, what we're doing this time is taking entire rucksacks, and we're going to group them into sort of sets of 3, and then find the letter or the group of items that appears in all 3, so isn't unique to each of the individual 3. And the end result is, or the end check is the same. So we want to find these individual letters, and we want to assign the priorities again. And then once we've looked at all of the different sets, we're going to go ahead and sum those priorities, just like in part 1. So this might make a little bit more sense as I start working through it. In terms of the first few steps, I'm going to keep those exactly the same because we still want to sort of take our rucksacks, split them up, and look at each different line within them to find the individual letters. So we basically start part 2 from the results of our regex tokenize. And as I mentioned, we want to prepare these by putting rucksacks into groups of 3. So all I'm doing here is taking the record ID, dividing that by 3, and then using the ceil function, which basically rounds that up to the nearest integer. So yeah, that just provides us of a nice record ID which resets every, or nice ID field which resets every 3 rucksacks, which is exactly what we want. So just scroll through a little bit, you can just see that happening a little bit more. Now, for the approach I've made, or the approach I've taken, I have basically taken the unique letters from each rucksack, and then within each group of 3 rucksacks, I've counted the, I guess, occurrences of that letter. And because we want to pull out letters that appear in all 3, I basically finalized this step by filtering for where that count equals 3. Because if the count doesn't equal 3, then that letter isn't present in all of the rucksacks. So we're not interested in it as sort of being the problem letter, I guess. So to do that, I've first of all used the unique tool again, like I did in part 1. But for this time, I'm using record ID and value. And the reason for this is, let's just take rucksack 1 for example, so record ID 1. Whether or not that has 2, 3 or 4 capital F's in, for example, I don't care about that. I just want the first occurrence of that in that rucksack. So this basically just gives me a list of all of the individual letters that are found in that rucksack, and whether or not they are found more than once, it sort of Ultrix just ignores that. And that's quite important, because the next step when we count the occurrences, if we didn't use this unique tool and we did have, say, 2 capital F's, for example, that would throw our count off, because if we had 2 capital F's in rucksack 1 and 1 capital F in rucksack 2 and 0 in rucksack 3, then that would still return a count of 3. So if we're doing a check based on that, then that would look to us like a problem letter, but it's not actually present in all 3 of the rucksacks. So it's quite an important first step to just take a raw list of letters that occur in each rucksack. Now, to perform our count, we basically want to use a multi-row formula, which allows us to look ahead or behind at other records. And we group by value or ID for this. So every time it finds the same value or ID, we're going to add 1 to the running total, which, as you can see here, in group 1, or ID 1, so rucksacks 1, 2 and 3, we've only found 2 capital B's. Whereas if we scroll down a little bit more, in group number 46, we found a capital B in the first rucksack, a capital B in the second, and a capital B in the third. So the final count for this ID is 3. And where we have IDs of 3, as I mentioned before, that means that that letter has been found in all 3 rucksacks, which is the premise for this part 2. So our final step before we start bringing in the priorities is just to filter out everywhere where we find a value of 3, because that means that letter has been found in all 3 rucksacks within that group. And then from here on, it's identical to part 1. So again, we've just got our lookup list of letters lowercase a through z, which correspond to 1 to 26. And then 27 to 52 are all of our capitals. Exactly the same as before, we're just conducting a join on the letters themselves and returning the priority. And then again, we just finish off with this summarize tool, where we sum our priority field, and this time that returns a value of 2,581, which was indeed our part 2 answer. So again, another day where part 2 isn't too much more work than part 1. You'll see as we continue on through these videos that towards the later days, the part 2s actually require quite a lot of change and applying different logic. But yeah, again, fairly simple for day 3. Really hope you guys have enjoyed this. Stay tuned for more. Thanks a lot.